Hello, everybody. I don't know you guys, but you guys definitely have not met me. I'm Aaron Hazel, and I am teaching computer science for Bronson. So we'll have we'll have time to get to know each other over the semester, and I hope my hopes for this course are that you guys take whatever I teach you and apply it to your lives and apply yourselves diligently in the class, and you'll be surprised at what you can achieve with computer science. And I hope that you guys come away from this course, inspired to dive into the world of tech. Um, for those of you who are taking this class, I'm assuming you guys have an interest in computers, and that's good because the future is in tech. There's a lot of interesting careers, interesting work. You're constantly at the cutting edge of industry, um, and you'll be around smart people. Uh, so yeah, I think the goal for this course is, for a grade 12 course, you're not gonna get into the 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 deep details about computer science, but our hope is that I give you guys enough to inspire you and also to give you a solid basis for which you can now go on and do your own learning and your own research and start to create new and interesting things. So that being said, um, today I'm just doing a little bit of an introduction. We're gonna go over some setup details that are key to doing this class and succeeding in this class. If you cannot if you cannot even finish or get through the setup, uh, then it's a big problem. Now, I'm not expecting that the setup process will go without errors, but this is something. This is actually typical in the field. Is that even people seasoned coders and programmers. I mean, there's always some sort of setup and installation they have to do with new technologies, and there's always troubleshooting. So you need to you need to be able to come away from this with the ability to troubleshoot on your own, reading documentation, following instructions, right? Uh, that's the kind of skill set that a computer scientist needs. You need to be able to follow instructions on a website. Um, oftentimes, we'll be working in the terminal, and a lot of these websites will tell you how to install their software from the terminal. So you need to be able to work in the terminal, or if you're on a Windows, it'll be the command shell, I believe it's called, and on Linux, it's very similar to what we have on Mac. Okay, so I don't say this to discourage you or to scare you, but to but I need you guys to take this setup seriously, right? This set this is just the first hurdle of many, right? Um, I can remember the troubles I had just starting to learn computer science, and the setup can be tough. So I'm trying to simplify it as much as possible, right? But also it's an opportunity to learn, and it's an opportunity to foster the right mindset coming into this course. This is not a course for people who don't do well on their own, right? You need to have the ability to learn on your own in this course, and but also questions are encouraged, but questions are encouraged after you have done your own extensive research and study and searching for answers, right? My expectation is that if you have a question, it's because you have exhausted all options on your own. right? That's the skill set you need. Not only do you need it for this course, you need it for computer science, period. If you're going to go and get a degree in computer science, you need the ability to learn on your own, research information, read documentation, follow instructions, troubleshoot, and not get overwhelmed and frustrated, right? If you are the type that at the first sign of difficulty, you're quick to just ask a teacher to solve it for you, then you may not be the right person for this class, right? That doesn't mean that you won't be able to do it in the future, but maybe it's something you need to think about now and say, okay, am I ready, right? So, um, yeah. So we'll go into some setup. So this course is gonna be dealing with programming, right? And so there's several different languages. Actually, let's look at let's see, popular programming languages in 2022. Okay, top programming languages. Oh wow! So coincidentally, we're gonna be doing Python, um, and it looks like Python is at the top. Um, I've taught the course before in Java. Java's been around for a long time, and you'll see it a lot in a lot of places. C, the C language exists a lot of almost every single device that you use has C layered underneath, right? So so these are some things that we're going to consider. So we're going to do Python. Python is, like it says, is an object oriented and interpreted language. There's different styles. C is not object oriented. SQL is it stands for structured query language, and that deals with databases. You've probably heard of JavaScript, and JavaScript is widely used on the web now, on the front end and the back end. So front end refers to things that the user interacts with directly. Back end is like data storage, servers, etc. So JavaScript is popular. HTML is not necessarily considered a programming language, but I'm pretty sure you guys know about HTML. And then here are some lesser known ones. This is a new Dart is a new one. I think it's created by Google. Swift is Apple's language of choice, and the list goes on. Eiffel, yeah, nobody should use Eiffel because it's not good. Okay, so yeah. So that being said, we're going to be working with Python. So what do we need? Well, let's just type in Python and okay, wrong page. I'm gonna do Python, and then you're gonna go to python.org. Now this is typical, right? Like we can go to, let's say if we wanted to do Java in this course, we will look, and then Java, we have java.com. So here's a little different. I think they've updated their website, but there's usually it's like this. You have documentation. What we want to do for today is we want to go to downloads, and then you'll download your version, right? So let's see. So the latest version is here. Okay, so you want to make sure that you're downloading for your operating system. Okay, and the version, as long as it's one of the it's in version 3, it that's fine. Nothing less than version 3. So I'm gonna download this. Okay, so here we'll have different files. If you're on Mac, I would I would click this one, the Mac OS 64-bit. Um, if you're on Windows, I'm not familiar with Windows, but here it says recommended. If you know that your system is 64-bit, usually most computers are 64-bit. You would choose this one. So I'm gonna choose that. Okay, and then I'm gonna go to my downloads. I'm gonna open the package. Okay, download, install. I have fast internet, so it went by pretty fast. Okay, so here, we're not gonna really use any of this, but this is um, idle is what we would call, I guess, yes, it's a shell. So the shell is like, it's similar to this. So if you're on Mac and you have the new Mac, this is the Z shell. And this here idle is a specific shell, which is like some sort of program or container whereby you can write Python commands, and it has an interpreter to interpret. So let me see. I've never really used this, but let's see. There. So I can type in a command, print hello. I can say name equals Aaron, that's my name. And then I can say print name. So what I just showed you there is, okay, how to print a message to the screen, how to store data. This data in quotation marks is called a string, and it is stored in a variable called name, and how I can print a variable. So anyways, we may use this for small programs because it's pretty handy, but I really want us to get used to using the actual tools that a developer would use on a day-to-day basis. Not that they wouldn't use this, but if you're making an app, you most likely wouldn't use this. Okay, so we have Python now, right? So what did we just do? Like, actually, let's actually think about that. What did we do? What did we actually download? So we downloaded. So if we go to documentation, and we can go to Python docs, you'll see this in like a lot of different languages. Like there's always documentation. So let's look at library reference, and maybe if things are going smooth, we'll probably dive into some of these things in here in this documentation. So let's look, for instance, math. So this is a module called math. I know we're don't get too caught up in understanding what I'm talking about, but I'm just giving you a very surface level presentation of the setup, and also just programming from a very surface level perspective. So anyways, so without going into detail, what we're looking at is actually all of the Python files that are packaged for us. So when we downloaded Python, we got access to this math. We have access to this math module, and this math module can do different things, right? It has an ability to do factorial, if you know what factorial is. Let's see. It can do It can do power and logarithmic functions, right? So exponents. So we may have an assignment where you need to do some math calculations. You'd probably use stuff that's in the math class, right, or math module. Now, that's the beautiful thing, right? So so often programmers, we we like to utilize the the work of other programmers. So you can say that you can actually say, okay, maybe it's copying and pasting, right? In a sense. So somebody had to write the math module and actually come up with the implementation of how to actually do a factorial and stuff, and they're able to package it in a math module that we can use without actually understanding the details underneath of how exactly it's calculating. And that, in a sense, is a key theme of programming. The idea of abstraction, what abstraction means. Now, I know many of you, English is not your first language, but and I never knew, and I didn't understand abstraction until maybe a few years into my program, right? But if you can understand the idea of abstraction by the end of the course, that'll be a great tool in your arsenal. Okay, so abstraction is like this. It's like, um, okay, let me think of an example. Yes, okay. Say you have a TV, right? And you have a remote for your TV, and you press the power button, and the TV turns off or it turns on. You can switch the channels, etc. Right? You're able to control the TV, but you actually don't. When you're pressing these buttons, these channel up, channel down, do you understand or do you know how exactly the channel is changed? No, you don't. Those details are abstracted away from us, meaning that there's a the designer has created a layer in between the electronics, the low level details of how the thing works, and we're given the controller. And all we need to know is that when I push this button, it does this, right? So that's abstraction. That lets us abstraction lets you extraction kind of deals with the level of detail that you're looking at, right? So if we're looking at programming, right, we're going to so the level of abstraction that we're used to right now is that, hey, I click on Google Chrome. I know how to type into the browser, what website I want to go to, right? But then there's another layer, the web developer. His layer of abstraction is he writes HTML code, JavaScript code, and CSS code to now display a web page. But then there's another layer below that. How the layer of the browser. How does the browser interpret the code that I, as the developer, write? And then there's a layer below that. How does the operating system handle the browser? And then there's a layer below that. Underneath the operating system is the actual what you call the motherboard, right? The chip, the processor, the controllers on there, right? And that's the lowest level. That's the lowest level. So that's levels of abstraction, right? At each level, there's somebody has a responsibility, right? So the computer architect, the hardware architect has the responsibility of developing the hardware, the chips, the processor, the RAM, the solid state drive. That's the hardware designer's responsibility. Then you have the operating system designer or developer or architect. And that's the people who design Mac OS, and they provide a layer on top of which the developer can now develop applications on top of that. And then on top of that, we have the user, which is us, who utilize apps that are in a operating system that do something useful for us. So that's abstraction. So I know we got off track here, but yes. So this is the documentation. So be familiar with. We will get familiar with the documentation. This is a grade 12 class. This is not grade 11. So we are not going to. We are going to be doing much more than you would in the grade 11 class. Okay, so we've downloaded Python, and now to verify, I think there's a command called Python version. Okay, there isn't. Let me see. So now this is what I was talking about, right? I've made an assumption about a command, so I can look at. I can search how to check Python version in the terminal. How to check Python version. So I just click on the first one, and it should, okay, so it's supposed to, so this is supposed to work. So this is on, I think this is on Windows. So this is the Windows version here, it says Windows, right? We want to know for Mac OS. Well, here it says that should work. Okay, so what did we do? Python version. Command not found. Okay, so this is good that we've shown this. I think because we're doing Python 3, they changed it. So you have to say Python 3. Yes. So you see, we put in Python 3 version, and here it tells us we're using Python 3.10.9. Okay? So we have Python. Now we got to assume, where do we write our Python code? Right? So far so good. I hope everybody's following, and I hope this is simple enough. Okay? Now, where do we write our Python code? Well, we use an application called Visual Studio Code. Okay? So this is Visual Studio Code. I have some code here. Okay? So, but I'm going to go through the installation. Okay, so just search for VS Code. Okay, I'm going to pause here for a second. Okay, I'm back. Okay, so Visual Studio Code. So I believe there's Visual Studio, and then there's Visual Studio Code. We want Visual Studio Code. Okay, now depending on what machine you're on, you'll get the download link that is works for you. Okay, so you download it. Okay, so let me just download it again and see. Okay, so we're downloading. Okay, so what's going? So I'm getting all these different errors. So let me see. I want to see. Okay, will be like the first screen you'll see. You won't see all of these. You won't see anything in the recent because you don't have any projects, right? But you'll see this on the left hand side. New file, open, clone, GitHub repository, open walkthrough. Okay. We won't worry about that today. I'm gonna do another video on something called Git and GitHub, because that's something else that we're gonna need. But this is gonna be the last thing we'll cover for today. So we want to go to extensions, and here just search for Python. And so I have this already installed. So you just want this. IntelliSense IntelliSense Pylance, linting, debugging, multi-threaded, remote. Okay, so you'll have a button here that will say install. What that's going to do for us is it's going to just make our lives easier. And I'll if I can just show you. Uh, let me. Okay, let me see. I already have some Python stuff that I've done. So let me just make a new file. I'll create a new um, Python file. So here is letting me create the file. So I'll call this ICS4U test dot py. Notice how the icon changed. Now your icon may not change for you because you had to change the theme, but it's recognizing that it's a Python file because every Python file ends with .py. Every Java file ends with .java. Every C file ends with .c, etc. JavaScript files ends with .js. CSS files end with .css. So it's okay. So it's not hard to. Okay, so now I have a brand new file. Okay, and here's just gonna be our. This is the first program that programmers always write. Hello world. Okay, so now we've written hello world. Now you want to go to the play button, the run button here. Run Python. And this is what we need to get used to here. It's gonna display the output in the so VS Code has its own little terminal built in, right? So it's pretty much the same as this white thing here. Okay, so this is the terminal, and here we see it says it printed out hello world. Here I can even print out just so you can see. Okay, and then I'll run it again. So there. So that's it. So that makes, just believe and trust me, is that if back in the day you'd have to write your code, all your code in the terminal. What VS Code does for us is that if I make a mistake, say if I say print L, there's no such function called print L, right? See, it's giving me so it's telling me print L is not defined. So it tells me if I've made any errors. So because we're gonna make a lot of errors. I mean, we're gonna miss certain keywords, right, etc. But with using this tool, is gonna help us to catch the errors and fix them, right? Because if we were doing this in a terminal, life would be much harder. So this is just, we're going to do this in a way so that we don't have to worry about the tools. We just got to worry about the code and actually how to be good programmers. Okay. So yeah. So if you have Python downloaded and you have VS Code downloaded, you're pretty much ready to start coding. Okay. And so so this serves as an introductory video for going through the setup. Now the setup is pretty simple, right? But you may run into errors. Okay, feel free to troubleshoot Google. Remember, troubleshoot. Google is your friend. Ask questions after you've tried your best. Don't try for too long, right? Don't waste 5 hours trying to figure something out. If you Googled and everything and you still don't understand, then that's fine. You can ask, and I can do my best. If it's Mac, I can help for sure, most likely. But for Windows, I'm not in a Windows machine, and I haven't used one for a long time, so I'm not gonna necessarily know. I'll probably be googling stuff to try and help you. Okay. And I mean, that's the life of a computer science. That's the life of a programmer. Someone who's making apps right now, a part of their day is Googling. They might spend 2 hours, 1 hour, 2 hour Googling things. How do I do this? How do I make a web page with a button that animates in this way, right? Google is a programmer's best friend. Okay, so that's something you need to get used to doing, right? How to search for information, how to ask the right questions. Okay, um, so I'm gonna stop here. So keep an eye out for another video going into part two of the setup, and this is gonna go into more detail of with regards to how we're actually going to be doing our assignments and something called version control. Okay. Okay, so I'll stop there.